Welcome to the Joy of Coding. Hello, and welcome to episode 161 of the Joy of Coding. My name is Mike Conley. It's 2019. How are you? How are things? It's been a couple of weeks. Yeah, I've been away. Holidays, been traveling, been seeing family, but now I'm back at work. I'm ready to get back into the swing of things. I hope if you had a holiday that you had a good one. And let's just get into it. So let me switch to my screen. One thing to note, I had sort of said, I hinted towards the end of last year, and in the last episode, I think, that I have this new streaming device. This thing right here, which will allow me to actually capture the HDMI output from my laptop here and broadcast from a second computer. And that will be super useful to avoid like the overhead of running OBS on the same computer that I'm like doing builds on. But unfortunately, I was going to use that today, but what happened was Windows decided to update. So as soon as I like started to update, I started to update like 2 hours ago, and it still hasn't completed. So that's not gonna work. Hang on a second, turn off the delay. It's still updating on my desk, the Windows machine I was going to use. So we'll have to hopefully use that next week, and then hopefully from there on out I won't have to worry about OBS overhead while streaming. Okay, so let's get into it. What are we doing today? Well, today is episode, like I said, 161. And a reminder, no plan survives breakfast. I have a sense of what I want to do today, but I don't know if that's actually what's going to occur. I have some points I want to hit, but who knows? Things might go wrong. Things might go sideways. I might get stuck. I might get sidetracked. Who knows? So if things go wrong, that's okay. That's what this is all about. And the second thing is that this agenda that we're looking at is something that you actually have access to. And that's handy because there are a bunch of links in there that you might want to click on. So how do you get access to this agenda? Well, it really depends on how you're viewing this stream. If you're watching this on Air Mozilla, there's a handouts section somewhere on either side of the screen. I think it's over here. It'll be there. If you're watching this on YouTube, then in the video description down below, there's a link to the agenda. And if you're watching this on Twitch, well, unfortunately, there's no place for me to put a link in Twitch, so I have to drop it in the Twitch chat. So I'm going to drop it in right now. Booyah shaka. There it is. There we go. There's access to the agenda. And along with the agenda, there is the episode guide I wanted to quickly shout out. So the episode guide is a user-driven or a viewer-driven repository of information about each episode. We've got all the way up to episode 159. I actually think that there is a pull request for episode 160 just waiting to be merged. Actually, let's take a look. I think Smurf D sent in a pull request and I just haven't merged it yet. So let's take a quick look. Pull request right here. Episode 160 is 10 days ago. I was on holiday, so I didn't merge it, but here we go. He adds episode 160, and then, oh, good on him, he adds the 2019 breaker right there. That makes sense. I think we use the double, the double hash there in the space and the new line. So that's right. And then in the episode, he's got a link to the actual Air Mozilla event. He's got a link to the agenda. That's nice. Well, what's interesting, he's got a link to the YouTube redirect of the he must have copied that from YouTube, the YouTube video. That's okay though. And then he's got some of the bullets of the things that we touched, and then the things I said would happen in 2019, and then some of the other stuff that I worked on. Oh, I want to. So this looks great. I'm gonna merge this in right now. So let's just do that. Whoops. Thank you. So merge pull request, confirm. And then I'll comment. So that's episode 160 is in there now. I don't know how long it'll take to update, but eventually it'll show up down there. And if you want to contribute to the episode guide like Smurf D did, then here's a guide in the episode or in the agenda. Oh, Happy New Year, Smurf D. Here's a bunch of links that Smurf D recommends. Here's a contributing guide. There's actually a guide in the repository for how to exactly to contribute that SmurfD wrote. And here's also a guide for creating pull requests that SmurfD used and recommends. So thanks, special shout out to SmurfD for keeping that episode guide populated with stuff. It's really, really something, and I really appreciate the effort there. What else? Oh, I wanted to mention something about my theme. You'll notice that I've got this blue theme I've had for a bunch of episodes, a couple of months now. And in the past couple of episode guides, you'll see that there's a link to how you can use my theme from Firefox Color. Well, recently Firefox Color, which is this experiment that at color.firefox.com you can install this add-on, and then in the web interface you can create your theme. Well, there's a way to export that theme now. And so I did that. I exported the theme to addons.mozilla.org. So now you don't have to install the Firefox Color add-on. You can just install my my theme called Electric Boogaloo. This is my theme. Electric Boogaloo is what I called it. And if you go to this link here, I'll put that instead of... Where's that been coming from? I'm gonna say no. So I've got here streaming from a PC via the HDMI interface. Hopefully, nope. But I am gonna put a link to theme on AMO. Whoops, move that cable. If you want to install my theme and not use the Firefox Color add-on, then there you go. That's how you can do that, and that's very easy. So what are we actually doing today? Let's get down to work. It's been a little while. Let's get down to work. So there's a thing that we worked on, I think, last episode. If I look, I think we worked on this. I did some mercurial stuff. No, I didn't, but maybe it was the episode before. Maybe it was in episode 159. Whoopsie daisy, didn't mean to, episode 159. Where is episode 159? There it is. Here's the pull request for it anyways. And I think I make reference to... No, this is new. Okay, so we haven't covered this before, or at least not in recent memory. And so what I want to talk about today is this thing that I wrote a year ago called Promise Document Flushed. Promise Document Flushed is this browser engineer only method that you can call on browser windows, and you pass it a callback. Let me see if I can find you an example of it being used. Promise Document Flushed. So there are a bunch of people using it now, which is nice. Actually, maybe if I show you some of the tests that I wrote for it, that will kind of help demonstrate here. So there's some tests here. Here are some examples of it being used. So let me pump up the font. What you can do with Promise Document Flushed is you pass it a callback, and Promise Document Flushed will call this callback whenever the window that you're calling Promise Document Flushed on has either no style or layout flushes queued up. And a style or layout flush is like the sort of expensive style or layout calculations that occur if the DOM is dirty. Effectively, it's like, call this function when the DOM has not been dirtied since the last paint. And sometimes sometimes the DOM is clean right away, in which case you can call this right away. And the reason we want to do that is because sometimes we want to get measurements. We want to know how something is styled, or know where something is positioned. Like we want to get the padding left of something with get compute style, or maybe we want to get the client bounding, the bounding client rect. And if the DOM is dirty, then that will cause an expensive layout and style flush. Sometimes just a style flush, but sometimes a style and layout flush, and sometimes just a layout flush. But usually that's because of a style flush. Right, it's just a style flush or a style and layout flush. In any case, something expensive occurs, and we don't want it to occur. So if the DOM is not dirtied, the nice thing is that these computations are actually really cheap, because we cache the size and position of things from the last flush. And so this function is supposed to access those things at a time when they're actually cheap to access, and then you can return the result to the promise. You can, like, this promise document flush returns a promise that resolves with the value that is returned from this callback function. So ultimately, the interface is like, oh, await this thing, and then in the callback, you do your measurements, and then whenever paddings is done when we're done awaiting, paddings will have these measurements, but we got them in a way that's cheap. So we avoid skipping a frame. So there's a trade-off here. We sort of relinquish, we hop out of JavaScript and let the page do a style and layout flush naturally, which occurs whenever, like, we're about, like, the 60 FPS or the compositor, the vsync occurs, and so we do a layout flush, a style and layout flush naturally, and then we get those values from that layout flush. So the trade-off is we might end up painting stuff that we didn't mean to paint, but if we pick and choose where we use promise document flushed, then we can actually save us from having to do those style and layout calculations more than once per frame. And that's good because style and layout are oftentimes the things that blows out your frame budget, and then you will, like, your 16 millisecond frame budget, which prevents you from doing 60 FPS animation and being responsive at 60 frames per second, which is what we want. So promise document flushed, it's great. Now the problem is that I think there's a bug in it. And the bug is because we realized, I'll tell you kind of how we discovered the bug, and then I'll go into my potential solution. Because I have already written the solution to the bug, and I can show you that solution. But what I want to do today is write a test for the solution. And what we discovered was that someone was accidentally confused, and maybe this is a problem in our documentation, but inside the promise document flush callback, they were altering the DOM. And that's not a thing you're supposed to do, because as soon as you alter the DOM, you blow away the guarantee that stuff inside this function will be cheap to query, like layout and style information will be cheap to query. And that's not only true for this callback, but any other promise document flushed callbacks that may have been registered for the same tick of the refresh driver. So we want to avoid any writing to the DOM, dirtying of the DOM inside these callbacks. So I wrote a patch to do that. Let's see here. I have a bug that I can refer to. Yeah, window promise document flush should admit diagnostic information when read-only treatment of the DOM is violated. So we can't lock down the DOM, but we can reject the promise. That's what I found out. So we have these things called mutation guards. And what I can do is, before we call the callback, I create this mutation guard, then I call the callback, and then I check to see if any of the DOM was mutated. And the number that I pass to mutated is like, how many DOM mutations am I allowed to make? And for, like, between this point and this point. And in my patch, I say 0. So we're not allowed to change the DOM. And if mutated 0 returns true, it means that something was mutated. And then that's when we reject the promise. And we reject with this no modification allowed error. And here's a test that tests it. So inside this function, I dirty the DOM, and then I assert that flushes are required, and then I use promise document flushed, and then I dirty style and layout again in here, and that's not supposed to, like, this should definitely reject. And so I assert that the promise rejects with a no modification allowed error, and then I clean up the DOM when I'm done. And so that all is good. That got patch approval, and it landed, but then it bounced. And it bounced because there's a bug in how promise document flushed works. And the bug is that sometimes, not often, we have subframes in the browser user interface. And one of the examples of a subframe is, like, in our dev tools, we this is all running in the parent process. These are like browser frames, and like this is a subframe actually. And like sometimes we have splits where like this is a subframe and this is a subframe, and they can be of different sizes. And so that's the same as in the inspector as well. And if we call promise document flushed on the containing window, that apparently in certain cases, some of the subframes might require a flush and will cause a flush if we attempt to access style or layout information, but the top level frame says, I don't need a flush. And so promise document flushed essentially is not checking to see if subframes need flushes before running the callback. That's the bug. And so I wrote this patch. I can show it to you. Let me pump up my font a little bit here. I wrote this patch. And I caught that in automation. There's actually a DevTools test that causes that bug because it's testing like the dimensions of things like the browser console, and it's using promise document flushed, and then it violated the invariant and caused the promise to reject. And we caught that whenever I pushed to try recently. So here's an example. I'll show you the try push. Right, where is it? Here, in this try push, you can see a bunch of orange. Those are test failures. And then if we look at some of these, yeah, there's like modifications not allowed for this document. There's actually a bug for that. That's interesting. Yeah, promise chain failed to handle rejection modifications not allowed in this document. Interestingly, this bug exists. 20 days ago it was filed, and then in the last 7 days on Autoland. That was 17 days ago. Okay, so this I think got closed whenever my patch got backed out. So actually closed this. This got closed when this got fixed when bug such and such was backed out. So I'm going to mark this fixed. And it was fixed in let me find where this got backed out. It's backed out 20 days ago. And it was backed out of Autoland. Yeah. Fixed. And it was like Central was never affected. So it's like unaffected, unaffected, unaffected. So that's fixed. And so we've got this promise rejection. And my question, what I've got is a patch that, let me show you what it does. So it's for promise document flush should ensure no subframes need flushing before running. And if I look inside the patch, I can show you how it works. And this is why I can't wait to have my secondary machine running OBS, because OBS is consuming like a full core. It's just eating up my machine's processing power right now. So I have this function called check subframes need layout or style flush, and it's somewhat recursive. It will be passed a document and this like void pointer or void star opaque data, and then that document, we can get a pres shell for it. And if there's a shell that exists, because sometimes documents don't have pres shells, if for example they haven't been inserted into the document or something, or perhaps they've never been displayed, they're early in their lifetime or that sort of thing. So I can actually cast the data. Let me show you actually where it's first invoked, because that will help explain the data. So it's a recursive function that enumerates the subdocuments of a document. So in the document that I'm calling promise document flushed for, I first of all create this Boolean. I call subframe needs flush, and I say, well, initialize it to false. Then I call enumerate subdocuments on the document, which takes a function and like a function pointer, or just like you pass it a function, and you pass it a reference to some data. And it's going to, this will all occur within the same tick. And what we do is we enumerate all of the documents, the subdocuments of this document. And if the document's shell decides it needs a layout flush, then we cast the data, which in this case is a bool reference or a bool pointer, to a bool, and then we set it to true and we return false. And when this the function that you pass to enumerate subdocuments returns false, that means forget about enumerating any more documents. You don't need to. We've found what we were looking for, so I return false. Now, otherwise, we check to see whether or not the document that we've just seen has any subdocuments. So we walk the entire tree, and we recursively call check subframes need layout or style flush, and we pass the same data. And then we return true, which means continue enumerating. So either we reach the end of the documents and we have need flush is false, or at some point we find a shell that does need a flush, and then we return needs flush is true, and we return false to stop enumerating. And then I change this part of promise document flush that is what calls the callback immediately if the shell does not need a style or layout flush. I also say, well, not only does the shell not need a style or layout flush, but any subframes also don't need a style or layout flush. If that's all true, then we are safe to call the function immediately. Otherwise, we will wait for the next refresh driver tick, at which time it is safe, presumably, to call that function. Smurf D is like, it's kind of amazing that OBS is not being optimized. The few streamers I look at least sometime complain about its performance. That is true, although I will point out that OBS is an open source piece of software that I think is a very small team of people. And the work that they do, this small team, it might even be one person, I don't know. But the fact that it exists and is maintained is incredible, considering how featureful it is. So I'm very thankful for the OBS people. I realize maybe I should just put my money where my mouth is and start looking at performance issues and trying to fix and contribute to OBS. That might be an interesting episode. I don't actually know where time is being spent, and maybe it's unique to Mac OS. If I look at the activity monitor right now, one of the things I'll notice is that not only is OBS taking a lot of time, but the Windows server is also taking a lot of time, a lot of CPU time, and I wonder if there's something related there. OBS is capturing information from the Windows server in ways that, who knows, maybe we can optimize. I don't know. I don't know what the cause is. It might also be because I'm recording at the same time that I am broadcasting. The good news is that with the separate machine, this should be hopefully not an issue. I have to test it still, the separate machine. So hopefully next week, fingers crossed. Okay, so we have this patch, and it appears to work. When I pushed it to try yesterday, a bunch of the tests that were failing came back green. I have these tests that are failing, but I think they're failing for an unrelated reason. There's a known intermittent that was filed a couple of months back, 5 months back, and I think it's known. It fails periodically, and it's not great, but the fact that we fixed a whole bunch of the other ones is, I think, positive. And this known intermittent hopefully will be fixed by someone else down the line. The sheriffs will eventually get tired of it and either find some way of fixing it. Ultimately, I think this is unrelated. This intermittent failure is unrelated, and we fixed the one that was related, so that's good. But I want to write a test for this for promise document flush. But the problem is I don't know how to test it. I didn't fully understand the scenario that caused the flush, the unexpected flush, to occur. And that's what I want to do today, is try and come up with a test. So what I'm actually going to do is pop this patch off and go back to this patch here. Oh, not Rebase. I didn't mean to Rebase. Yeah, my disk is really busy. That's why Watchman is all it's all slow. I wonder if OBS is just being really it's doing a lot with my disk. That could be. If I look at like input and output. What's happening? OBS. It's actually not doing a whole lot to my disk. So perhaps it's just like holding a lot of the frames in memory. That wouldn't be great either. Or maybe I'm just misunderstanding how this all works. At any rate, there's nothing different about my repository. There's nothing in the working directory, so I'm actually going to go back one revision. I'm going to build, and meanwhile, I'm going to try and understand how we got into the failure case. And the way I'm going to do that is actually using a separate machine. So I have beast mode in a state where what I did was I put an assertion. I'll show you. Beast mode's my Linux VM which has RR on it, and RR will be our tool du jour. And what I did was I modified my patch so that just before we reject the promise, we crash. Because crashing is a great way of signaling to RR that something interesting has happened. And then we crashed, and I ran the test, and I hit the crash, and it's a little racy, so I had to use chaos mode, and eventually I hit the crash. And I've got us in the state where we're at the crash in RR. This is exactly what you want whenever you're working with RR, where you're at the point where the problem occurred, because now we can actually go back. And so what I want to do is I want to understand, I want to document and understand how it is that we are running this callback function, and where presumably the shell was like did not need a flush, and yet one of the subframes needed a flush, and we still caused that flush. So that's what I'm kind of hoping to piece together today, so that I can write a test case for it. Because I have a feeling this is a pretty, I think this is a weird edge case. So first of all, I'm going to build this. And while that's building, we're going to go back to RR, and we're going to take a look at where we're at with a backtrace. The good news is that RR is running on my virtual machine on a different computer, so that means that hopefully its processing is unencumbered by OBS. So I can tell that I'm running some JavaScript. I'm running the promise document flushed callback, or I'm calling it immediately because I'm calling it from promise document flushed. So I must have computed that none of the subdocuments needed flushing. Or no, sorry, I must have computed that the document that I'm calling it on didn't need flushing, and then I'm calling the callback immediately, and that caused a mutation whenever I called the callback. And I want to know how that mutation occurred so that I can replicate it. Connection to server timed out. What are you talking about? Must be talking about the SC cache server. My disk is encumbered. Okay, so I wanna go back to the past a little bit here. So I don't need to resume. We're gonna quit out of that, and what we're gonna do is first of all Control X. No, Control XA. That's the one. Control XA. Fun tip. Here, I'm gonna put this in the notes. Fun tip for if you're ever using GDB. Control X and then followed by A. Bring in GDB. So that includes RR. Allow splits the interface so that you can see the lines of code you're dealing with and have a console below. I learned that trick last year. So like now I can like step back and see that step back. So like reverse next, for example, well, we can see ourselves work our way up. Reverse next. Right, so now I'm working my way up. So Mutation Guard, the way Mutation Guard works is, let's take a look inside the implementation of Mutation Guard. The way Mutation Guard works is there's this static count called sGeneration that is modified anytime the DOM is changed by way of did mutate. That's a static function on Mutation Guard. So that will increase the static value, and whenever you create a Mutation Guard, it records what generation sGeneration was at whenever it was instantiated, and then when you check, it looks at the starting generation and diffs it with the current generation and sees if there's a difference. So what I'm actually looking for is between the point where we create the Mutation Guard and whenever we call, like exit this call function, what increased the value of sGeneration? That's the question. So I'm going to reverse next here. Okay, so this is, at this point, we haven't called our callback function. So let's take a look. So presumably the guard has seen 0 mutations yet, like at this point. So what I'm going to do is I'm going to look inside the Mutation Guard, and we're going to look at the M starting generation. So 25862. And I will also want to know what the static generation sGeneration is. So if I can like say ns mutation guard sGeneration, that should be the same thing. Right. Now what I want to do is I actually want to watch that value. I want to say watch the location of the static generation value so that when it changes, I want to know what changed it. So now I'm going to say next, and I'm going to say, okay, call our callback function, and hey, we hit our watch point. So something has mutated the DOM, and this is what we want to know. So I'm actually going to exit that mode that allows us to see the code, because I want to get a backtrace, and I want to see more, get more screen real estate. And we are inside did mutate because something has set an attribute. So this is what I want to record in my notes. Copy. So active bugs. This is the stack that causes the dev tools mutation. Right, and so we're setting the attribute on some node, so that's definitely dirtying the DOM, and we're setting that attribute because we're actually finishing the reflow of a scroll bar. So we caused a reflow, which caused an attribute to be set, so that's interesting. Instead of actually directly touching the DOM, we cause a layout flush. Right, that's the issue. We ran the actual dirtying the DOM is a side effect. The real problem is that we shouldn't have caused a layout flush if we were running the promise document flush callback. We should never have caused a layout flush, and yet we did, and that's the problem. So the problem, the layout flush seems to be caused by getting the client width of something. And if we look at inside the, we try and get the JS stack, then the reason we're causing a flush is because on line 566 of this file, so let's find that. What was it? DevTools client inspector, inspector.js, and the line was line 566. So we access the client width, and we're being called, we call this function use landscape mode in this function called on lazy panel resize. And that function's being called because we're running a timer callback. So inside on lazy panel resize, we ran a timer callback, and then we said, hey, so we're inside a subframe at this point, and we ask the top level frame, wait until all the frames are done flushing, and then call this function. And this is what causes a flush, which it shouldn't, but it does. And then that causes the DOM to be dirtied. So we actually have detected a case where promise document flushed actually will run even though a flush is required. So that's the bug. Now I want to be able to recreate this somehow. Why is this flush occurring? That's my question. Why is this flush occurring? And the flush is occurring because we're getting a scroll frame. If I remember correctly, because I looked into this a little bit, we have process, handle posted, reflow callbacks, reflow finish, reflow for scroll bar, flush pending notifications, get primary frame, get client area rect. So here's what I'm going to do actually. I want to know in between the point where we call, no, I want to understand why this frame needs to be flushed. So I'm going to go up the stack a little bit. I'm going to go all the way to let's see here. Where's a good place? Pres shell, do flush pending notifications. So I'm going to go there. And I'm going to see M needs layout flush. Is that true? Oh, wait. I'm inside the pres shell. This, what am I? I'm a pres shell. And so shouldn't I, as a pres shell, need layout flush? Huh, where is it? Maybe it's NSI pres shell, which is a slightly different interface. M need layout flush. So if I cast P Mozilla or NSI pres shell this M need layout flush. Oh, whoops. I need to do it like that. I don't know if I even need those outer parentheses, but so we do need a layout flush. That becomes true. So the subframe knows it needs a layout flush. That's good news. So the good news, whoops, didn't mean to open calculator. The good news, let me bring this up, is that the subframe knows that it needs a layout flush. So we just need to check that the subframes M need layout flush and M need style flush are false, like our solution does. So the real question is, the question I'm trying to answer, how did the layout flush, how did the mNeed layout flush get set, and how come it didn't end up changing the mNeed layout flush on the parent frame? Okay, so what I'm going to do next is I'm going to disable my first hardware point, and I'm actually going to delete it. And what I'm going to do instead is I'm going to set a hardware breakpoint on mNeed layout flush. Let's see what sets that to true, and I'm going to reverse continue. Okay, so something has set it to true. The old value was true, the new, okay, because we're going backwards. So the old value was false and the new value is true. I know that's reversed here, but that's because we moved backwards in RR, and RR is saying, well, we started it at true and then it became false. And because we're moving backwards, that's the point we care about. So what has set need layout flush to true here? Let's take a look at our backtrace. And it's some JavaScript that we're actually calling. It's inside this get client width thing again. It might actually be the same tick. Let's call dump.js stack. We might be in the same call here. Use like 566 again. Yeah, that's the same. So in the very same access to client width is causing mNeed layout flush to true. Now, why is that? And that's because frame needs reflow. Because why? Because style frames, because there was a style change. Process restyled frames. So what changed the style is now my question. So I'm actually going to where am I right now? Set need layout flush. PM needs style flush is false, but apparently we do need a layout flush. Why is that? Frame needs reflow. Why is frame needs reflow? Because style change reflow. Oh, maybe the style flush is already completed. So what I'm going to do, here's what I'm going to do. I'm going to say watch the location of need style flush and disable our, and then I'm going to set a breakpoint at ns global window inner promise document flushed. So that way we don't go too far. And then we're going to reverse continue. Need style flush is now true, and or was true. Old value is false and the new value is true. Here's where it was set to false. So I actually want to keep going because I actually want to know when it became true. So it was actually already true. It was true before I called promise document flushed. Okay, that's interesting. So before calling promise document flushed, the subframe pres shell already had, here, I'll pump up the font, already had mNeed style flush set to true. Okay, reverse continue. So what set it to true? Okay, set need style flush. Why? Because an attribute changed. We set an attribute. What attribute? We set a width. We set a width on it. We set a width on this attribute and call dump.js stack. Where did we set that width? Set value for styles, update DOM properties. Inside some React stuff, we have set some value. Unfortunately, that makes it kind of difficult to know, like this is batched work that set the width of something. Now, what is the thing that we set the width on? Maybe that's a thing we can determine. Set width. On an element. Set atcher right here. So I'm gonna let's see if we can get the ID. I'm trying to remember how to do that. Element.cpp. And element.h. Or ID. Oh man. Space ID has atcher. I want like the actual element ID. Pre-ID maybe change. Just call for the ID attribute changes. Okay. Pre-ID maybe change. Let's see how it does that. Name remove from ID table. The name of the attribute is nsgk items ID. Has ID. Do get ID. Interesting. And then can I get the value from the atom? So p this or do get ID. Oh, capital D. Huh. I don't know what that means. But we segfaulted. Assertion failure. Huh. This thing maybe doesn't have an ID. 197. So this thing doesn't have an ID that we're setting the width on. Does it have a class? Attributes. Can I get an attribute list? P attributes. It's an attributes map. Okay, is there like a way I can like iterate the attributes? Maybe C. Can you just like dereference that and print it? What do we have? Attributes. Probably some kind of hash table. Can I get the keys of that hash table? Let me just get the values. Or let's see if I can get the class. Attributes. Set named item. Get elements by class names. No. Class name and attribute value, single class name. How do I create an atom? That's atom. So can I be like atom attribute value set to a parsed value. Value. How do I create a new atom? Get as atom. Parent node info name atom. Or maybe I can find out what my node type is. Let's start there. Node type 1. I think that means I'm an element. Cool. Wish I knew what my inner HTML. Get markup. Void inner HTML. Can I like dump the markup somehow? If I create a string buffer. Dump content. File out. Dump. List attributes. Hey, that'd be nice. List attributes. Only in debug builds. Well, thankfully this is a debug debug attribute. So can I pass standard out? It's been a while since I've done this. GDB call with file argument standard out. Debugging with piped input. That's not exactly it. How do I call? Element dump content. Let me see if I can find an example. Dump content. Dump content. Nope. Ooh. A-frame dump frame tree. It's not exactly right. What's a good way of calling it? File is a type of structure. It's been a while since I've had to deal with this stuff. Oh. Good man, Marcus. I didn't realize you were watching. P dump content, standard out, 0 false. Let's try that. Haha, what is this? Well, first of all, thank you very much, Marcus. Nice. What am I looking at? This is something. This is just empty stuff. This is the thing that we are changing the size of. Presumably, this is something that React knows how to turn into something useful. Thank you, Marcus. It's got a button. Okay, so we've changed the size of this. By changing the width of this, let me think here. So maybe my test case needs to be like this. I've got a parent frame, and I've got a child frame. And inside that, I've got some element, X. So perhaps what we need to do is change the width of element X and then check to see if parent frame does not need layout flush does not need, well then, because then there's a style flush as well. Like the style is applied and then it needs a layout flush. So I need to like flush styles. I think here. Because I want to get, okay. Does not need style or layout flushes, but child frame does. If so, we've got our test case. Now the thing is, I tried to write a test case for this yesterday, and I failed. And let's work off of what I started with, which was, I think, all this gunk. So let's unshelve that. We can work with this. Man, what a great tip. Thank you, Marcus. I learned something new today. That's me unlocking like a new skill, how I can use dump content. I didn't realize you just had access to standard out. I guess it's just like you're basically in kind of like, I guess standard out is just like another file from C's perspective, from like the Unix perspective. It's just another thing. Like I guess standard out must be of type file, which makes sense. And on a POSIX Linuxy system, almost everything's a file. Just stdio. All right, so applying this change is taking a while. But I can at least show you what I'd started to write, which was, well, first of all, I modified some of the helper functions. If we go to the file here, I can show you. We have these like helper functions. Assert no flush is required, but just like apply only to the current window. And because we're dealing with subframes, I need to be able to pass a different window. And so I modified them so that they can take an optional window argument. And then what did I do? I also wrote this function called assert function does not flush, which attaches a reflow observer and runs a function. Because we're trying to detect the case where promise document flushed, the function inside runs even whenever reflows aren't supposed to run. So I have to have some kind of trap for a reflow did run. And that's what the reflow observer can be used for. And then I wrote, what else? Oh, it's cut off, unfortunately. We just need to wait for that to finish. It's just taking its sweet time because my disk is just getting hosed or something. OBS doing its thing, taking over 60% of my CPU right now. What the dealio? The good news is that I'm not dropping frames at least. Yeah, next episode. Can't wait. Really want that separate machine. In the meantime, while I'm waiting for my machine, I'm just gonna play some sounds.
I can't do my work. What happened? Hey, what happened? Hey, what happened? That's right. I can't do my work.
There you go. Oh, I just realized there's like really annoying glare. How do I get rid of that? Makes it worse. I think I need to iron this thing. It's catching the light. I need to iron this green screen. Sorry about the streaks. Oh, finally, Mercurial decides to merge my stuff. Thanks. This is crazy. So for the people who work on Mercurial or care about Mercurial performance, this is a video recording of a test case where it's a very simple patch. I'm just trying to unshelve a thing, and it's not a very complicated thing I'm unshelving, but it's taking forever. And let's take a look at what's eating my CPU. Unsurprisingly, OBS is taking 100% of it. Kernel task, 246%. 423% of it. So many cores. Python's taking a lot of time. And Windows Server. The good news is Firefox is not in this list, or it's not even in the top 10 right now. Good on you, Firefox, for lowering your CPU usage. Like the closest thing I've got is a web extension thing is running pure. Oh, your web content woke up 27%. Spoke too soon, but then it's back down again, 1.3%. Oh, and then Firefox itself woke up 7.9 and 3.9. But that's not even close to what we're dealing with up here. It was a very logarithmic. I don't know if logarithmic's right, but like there's a very steep fall off there. Wow, Mercurial, get your stuff together, or pack your bags. What's going on here? Well, at the very least, let's see if we can. What do I do? What do I do while I'm waiting? Ooh, there's something in the Twitch chat. Maybe it's running Clang format, says EvilPie93. Ooh, maybe. Except that, like, this is a JS file, and it's only a JS file. Maybe it's running ESLint. I wonder if it's running ESLint. Although, in that case, I would expect to see, like, Node. I would expect to see, like, Node in this list of things that is taking forever. Like, maybe let's take a process sample. See what you're up to, Python. Meanwhile, SmurfD has said that he's found an interesting way of using NSAtom. Let's take a look. In the meantime, what's this process sample say about Python? Python is eval. It's going deep. Hi, Malik. Maybe I'm just swapping a lot. That could be. Am I running out of memory? Let's take a look at our memory report. Malik. No, I've got plenty of, I mean, certainly there's a lot of memory being used right now, but I've got plenty of free memory, it looks like. Is there anything I could, like, free up some memory from? Like, maybe if I close some tabs and shut down some content processes. Tabs for the computer gods. I will sacrifice a tab to the altar. Yay! What? Unshelve already in process. Conflicts. There was a conflict. What's the conflict? Working copy. Oh, right. I had originally based my patch off of the patch that fixed it, and then I disabled my fix. So what I can do is I'm going to just remove that chunk for. Oh, actually, yeah, I'm just going to remove that chunk for now, and that will allow me to resolve that merge failure. Was that what it was dealing with? Was a merge failure? So in the end, unshelve continue. But I can at least look at the changes I had made. So now instead of, I got rid of, I had like a helper function, or like a short, I think there was like a shortcut to window utils, which window utils has gotten a lot easier to get access to. You just call .window utils on the window. So I didn't really need that anymore. So I removed that, and now I can pass this optional window parameter, and if we don't pass it, then we default to the current window. And then maybe to make this clear up here, I should actually just rename that win. And then flow function observe func. saw reflow equal false. And then I'm going to say saw reflow equals true. And then I'm going to copy all that and reload file. I'm going to paste it all back. And that's to get around Sublime being all squirrely. And then I'm going to say if saw reflow, if not saw reflow, then assert OK. True, did not see any reflows. So that's a quick and dirty way of doing that. Now for this test, what I was doing was I created a new browser and then I created an iframe that I put inside the nav toolbox, just for lack of a better place. And then what did I do? I gave it a style and a height, the subframe. And I appended it, and then I waited for the document to flush. I was playing around with resizing, but that I don't think is what I want to do. I actually think what I want to do is send it to this page. And then instead of getting the body, let's get the target. So this gets the, I might have to wait for the subframe to load, but at any rate. So I get the target, and then what I want to do is assert flush is required. So I'm going to assert at this point that flushes are required on the window, and then I'm going to wait for promise document flush to run, and I'm going to say assert no flush is required on the window. And then, or maybe what I should do is actually assert that out here, assuming that nothing has changed the DOM in the meantime. Then I change the source, or maybe I'll do that first up here. And it's got a div inside with a width and the height. So flushes are required. So no flushes are required. Then again, I get the target, and then I'm going to say target dot width equals 1000. Oh, style dot width. And now I'm going to say assert no flushes required when, but I am going to say assert flushes required subframe. Let's see if that's true. Let's just run that. Now actually, I think because I popped, did I build after I did, after I went back. That's good. So I'm gonna build faster. I don't even think I need to do that. I didn't actually add or remove any files. I can just run this test now. I should have just done that. Oh well. More processing. So for the people who are working from home today, I hope wherever it is you're having a good time. You're nice and comfy at home. I can tell in Toronto at least, It's quite cold outside. I mean, it's not brutally cold, but this morning I woke up and I went outside and it was quite cool. I had to put on a scarf and my jacket, and like I mean, that's not super surprising. It's the beginning of January, but up until now it's actually been remarkably warm. So today I think was the first day I was like, whoa, it's cold out. So let's run our test here. And actually I should be able to run this test headless, because I'm pretty sure whenever I ran it in RR here, I think I was using headless mode. So that means that the layout stuff that we rely on should work in the headless case, I think. Hopefully that's cross-platform. I think it's cross-platform. Sort of. Parts of it are. I don't see why it'd be different. Run the test. Creates a new window. Jams a thing. It says target is null. Target is null on line. Content doc subframe. So maybe we have to actually wait for this thing to load. That doesn't surprise me too much. Let's see here. Let load loaded equal browser test utils wait for event subframe load, and then I'm gonna say await loaded. I'm going to run that again. I'm going to run it in headless mode. So let's take a look at that thing that SmurfD linked to. He's like, hey, there's a way you can get, if you've got an atom, an NS atom, you can get the ID. Now, whether or not that's the actual ID of like a node is an interesting question, because that's how, I see. It's not on an atom itself, but you can go element get ID and it will return an atom, and then you can like tell it to emit a UTF-8 string. I see. That's handy. And then you can print that out. That's cool for next time. I don't think this thing had an ID though. That's okay. Certain flush is required on line 41 failed. And we're just sitting here. Are you running at all? Oh, this was the previous test. It looks like we haven't even kicked off here. What's going on? There we go. OBS. OBS. Why so slow? OBS. CPU load. OBS. Look at that CPU load. Let's pull up the graph here. Every core is lit up. It's running our test. Now, this is what I was afraid of, because I was dealing with this yesterday. It's pretty strange. Maybe I'm just missing a thing, but like this load event never arrives, which is weird because I thought that's how subframes worked. Like subframe here, subframe.source equals and then you wait content task, wait for subframe to load, you wait for the load event, and then they append it to the body. Huh. feeling we have a weird case here. Did we run out of time? Timed out? Yeah, we timed out. Dump. Waiting for load event. Let's see. Maybe what would be simpler is doing this inside a non-remote tab. I think I can still do that. And then like loading a subframe inside that non-remote tab. Because I think that's closer to reality, like closer to what the DevTools case does. Because I got a feeling I'm dealing with some like weird case here where they really don't expect an iframe to be just like jammed into the to be jammed in the browser UI like that. With new tab, options. New foreground tab, options. Options. For load. Force new process. Load URI. This remote browser. How do I want to do this? Thinking. So let's do it this way. Await, new, await. We're going to point it at a way I can force it to be non-remote. Yeah, there's certain Chrome URIs, like where could I send it to? Like, I don't even know if this will help, but Chrome.xhtml. Chrome global content Mozilla. Like, what's that? Is that about Mozilla? Yes, it is. So maybe we'll load that. And then it takes an async function.